Hello, hello. Awesome. Nice to see everyone. Yeah, if you're watching at home, there's like, what, 300 people here or something like that? It's crazy packed. Super awesome. Cool, let's get into it. I'm like in front of the screen, so maybe I'll adopt a sitting position too. Um, yeah, hey, I'm D Mars. I don't know why sitting. I feel like I should have like an acoustic guitar. um, yes, DMars, self-described credible auctioneer at Flashbots. Someone has to make the auctions credible. Yeah, so I'm going to be talking about some software we've been working on for a while, Rollup Boost, and how I think it's supercharging the superchain in a few cool ways. Cool. Let me move this. Cool. I'll go through four things in this talk, so I'll just get right into shilling. What is Rollup Boost? I'll describe a dream, internet scale rollups. I'll talk a little bit about what we're doing to get there, and then also I'll show a slide at the end that we're hiring, and really that is it. Actually, most of its purpose is me bringing up that we're hiring, so please go to our career channel. Okay, so what is Rollup Boost? Before this event, I went outside. I asked someone, what do you think Rollup Boost is? They said it was the most Milady-aligned software. Small joke. I see a couple Miladies in the audience, actually. Cool. What else is it without describing it? It is powering features on two of your favorite chains, and I think two of the coolest chains in the superchain, Unichain and WorldChain. So for Unichain, Rollup Boost is behind its use of provable block building, which allows us to do verifiable priority ordering. There's a lot of cool things you can build on top of this functionality. And then also, it's being used for creating this concept called flash blocks, which are these like 250 millisecond partial blocks. I'm not going to go too into the details of a bunch of these features, but I will mention them throughout the talk. And then the other cool thing it's helping with is WorldChain's human prioritized block space, which is a really cool effort to, as you can see in this title, reclaim the blockchain from bots. I think, I'll get into it later, but as we scale, there will be more and more bots as we scale these chains, and so we need ways to actually make sure block space is being prioritized for humans. Yeah, so some more definitions. It's a software. It's a software sidecar. It's this tiny thing. You run an OP stack. You put it right in between two components, and now you're able to talk to a new piece of software, a block builder, which can do all this cool customization for you. It can do you can enable things that improve the user experience, as well as leads to new avenues for decentralization. Another way you can think of it is it's a piece of software that has these like different capability modules. So these modules are either for performance, user experience, or decentralization and programmability. So I'll get a little bit further. So what is the software perspective? As I mentioned, it's a sidecar. So this sidecar, it sits right in between the OP node and OP Geth, eventually OP Reth as well. And what it does is every time there's communication between these two components, it will just pass it on to its normal OP Geth, just the usual flow. But every time there's a request for a block, it will now be multiplexed to the block builders, and that's where like the magic can happen, and they can produce a block based on your specific constraints. Yeah, we had 4 design goals when building it. The first one was security through simplicity. There is an insane amount of work that goes into securing the OP stack. I don't know if you've ever seen I don't even know what they're called, but sort of the diagrams that explain the auditing and testing process. It's like more than like 20 people can comprehend. So we did not want to mess with any of that. And so our hope was to keep it as simple as possible. I think the other day we actually noticed one of the main files is like 600 lines of code, and we're like, we need to cut this in third. So that was one of the big design goals. Customization through modules as well. We've implemented countless features on layer one for block building. And one of the biggest things we've learned, and especially enabling other block builders to build features, is just like modules are the only way to go. And also, a lot of the new blockchain clients are sort of built in with this modularity from the start. And so that's something we were heavily inspired by. Liveness fallback. We wanted to make sure that even if these block builders go down, your typical happy path, or sorry, like I guess it's sad path, sequencer flow is unobstructed. Blocks will still get delivered. Transactions will get confirmed. Yeah, and then minimal forks as well. In the early days when we actually started building a layer 2 block builder, we had like 2 different forks and it was already unmaintainable. And then 2 parties that tried to run it were like, hey, we're already running like 7 different OP stack forks. Could we not do that? And so that was another reason we went through this approach. And yeah, I'll show this a bunch, but open source from day 0. You can check out the code base. So a little bit more zoomed in. I don't know if I'm blocking this. You get this view. Yeah, so this is a very high level flow. You could think of it as user transactions, they come in. I'm not really talking about trust execution environments in this talk, but that's like a big component of this. You can think of it as like a piece of hardware that is like locked down since it's been manufactured with a private key, and you can encrypt things to that private key, and now no one except for that piece of hardware is able to decrypt it, is like the very high level. So we run a block builder in there. So user transactions, they come in, they could be proxied through another RPC as well. It depends on what type of privacy you want in the system. If you want the user like end-to-end terminating TLS connections with the TE, then you probably want it directly talking to the block builder. But in the beginning, for most chains, I think it's going to just go through like a load balancer. Yeah, then there's an ordering module. So for Unichain, this is priority ordering, specifically to enable MEV taxes as outlined by Dan Robinson and Dave White. And yeah, one of the cool things there with priority ordering is so native Geth does do priority ordering, but there's actually a bunch of these edge cases where it doesn't satisfy priority ordering. So like one example is if you have 2 nonces that are sequential, sometimes Geth, like on certain conditions, Geth will include your lower one just so it can include the higher one, and this will like violate the priority ordering constraint. There's some other small ones. And then the other cool thing is that like you can just verify it. So like anyone can just like hit this node and verify the ordering algorithm. And so you can imagine in the future, you're talking to maybe multiple different chains at a time, and you can see like, oh, this one does this ordering rule, this one does this, and probably there'll be some proxy software in the middle that'll handle the execution for you. So you as a user don't really need to know, but this is how we enable more like modular systems. And then yeah, execution engine. And then what comes out of it are these T-attested flash blocks. So we break the block into partial blocks. This is a design heavily inspired by shreds in Solana. And so what they do is instead of propagating a full block, they chunk the block and just start blasting it out as soon as it's ready. They also do other cool stuff like erasure encoding it so that they can like use UDP in case some packets get dropped. We're not doing any of that right now. All we're doing is just these like, almost like 4th blocks or like 8th blocks. And these will have like a 200 to 250 millisecond confirmation time. And then the other cool thing is that we built this with the ETH JSON RPC compatibility in mind. So we had built countless like pre-confirmation protocols in the past. They all modified the ETH JSON RPC in some way. And the big pain point then became, oh, XYZ wallet doesn't want to support it, or this one does, but they want to tweak, and the other one wants this tweak. Like, no, we're just using the standard ETH JSON RPC. And how we did that is we overloaded what is basically a vestigial property in the RPC, which is the pending tag. On ETHL1, this was sort of put in there like 4 years ago. You used to be able to ask a node for its like pending block, that's like best built block at the time, and it would give it to you, which is like kind of crazy now in MEV times. So we just repurposed all of that for, serving these pre-confirmations. Cool. And then another cool thing is that Unichain will also have like Unichain validators constantly like signing off on these blocks to try to give you some increased assurances about finality. And then, yeah, you can see at the end, L2 block, all good, all is normal. Yeah, I think there's also like a lot of conversation around like why things are even structured as blocks right now, but that's a different discussion. Um, yeah, so this is more the product perspective then. So it's a platform for roll-up capability modules, as I said, powered by TEs. Coming out the gate, there's multiple open source modules that like people could easily configure. One of them is human prioritized block space. World has some other cool tech on top of that to actually include a ZK proof of like humanhood inside of it. So you know that may be a little bit harder to fit in, but then on top of that we have verifiable ordering, T encrypted mempool out the gate, which is really cool. So if you're a chain operator, you know the trust model you have with your users' order flow it's a pretty strong story right now. Like it's very unlikely that say like Base is gonna like front run you. But a lot of chain operators don't actually want to have that power. They want to say like, no, we literally cannot see this flow. And so that's really powerful. And then Flashbox, as I mentioned. There's 2 teams building hack prevention solutions on top of Rollup Boost as well, Phylax and Forda. On top of that, multiple other teams are discussing possibilities. So another comment, Milady from the crowd. Yeah, I think if I had to TLDR this, it would just be Rollup Boost is the best way for your rollup to keep up with latest technology without having to like fork it or, you know, hire like 6-person R&D team to figure out if you even want this feature before you build it on a fork and try to productionize it and then, you know, realize you don't want it. And some more comments on this are, I think there's like a flywheel here we're trying to build. And so at Flashbots, we're an R&D collective. You know, the innovation word is like, you know, the holy grail. We almost try to squeeze ourselves into weird forms to try and maximize innovation coming out. And so one of the cool things for us with the Superchain ecosystem is we had a million block building ideas or like ways that we could improve the user experience through block building. None of them could really land on L1 because there was like all of these like validator politics or like, you know, you have a block builder who pays a couple $1 million to buy Flow and now 20% of the blocks are like, you know, not usable for this feature, like things like that. Not commenting on any of that other than just like it made it hard to innovate. And, you know, it's a maximally permissionless system. So like, you know, this I think should happen maybe. But yeah, we're excited that like you know, more chains using Rollup Boost leads to more rollup innovation. And so this kind of creates a flywheel. So once there's more modules, more chains want it. More chains want it. They have some unique, quirky feature they think is cool. You know, we help you build it. It's now an open source module anyone can use, and you keep building this flywheel. And it really reminds me of this meme of, I think Elon Musk tweeted when he launched the Roadster into space, like, turns out if you blast a rock with enough photons, a car will emerge. I think if you blast the Superchain ecosystem with, you know, enough users and innovation, internet scale rollups will come out. And I'll define what internet scale rollups is as well. I have a bunch of abstract philosophy related things after this, but I don't think we have time for it. So I'll just leave you as a teaser. Okay, internet scale rollups. Internet scale rollups, what are they? Sub-second and sub-cent, permissionless and safe, customizable. I think these are the 3 things we need to have, you know, just your average developer at, you know, whatever college, he's a freshman just learning how to program, wants to deploy his first backend service. Like, these are the things we need to make that a reality where they could just like reach for a blockchain. Right now, it's just incredibly tough. You have to think about like bridges and you have to think about like running a bunch of components and all this stuff. Like, I think it's, yeah, there's a lot there. So I'll sort of dive into a bit of a ramble on each of these 3. And then a small disclaimer is like, I really want to harp on permissionless and safe. You can easily just yeet permissionless. This is like what total anarchy sequencing is on the layer 1, this like proposal by Vitalik. Anyone can run your chain. Cool construction, but like, if you want users, you should make sure things are safe. I think that's probably not too controversial. Cool, yeah. And then another thing too is from rollup.wtf, like megas per second TPS. I think we need to like 1000x these for internet scale rollups, but I think we're not that far away. Maybe a hot take. Okay, cool. So there's a bunch of words here. I'll try and go through them. So sub-second flash blocks we think has like a very credible path towards being a solution for the OP stack in the long term. There's some conversation of like, would you rather actually just decrease the block time to like 200 milliseconds instead of doing these pre-confirmations? I think that's an interesting design discussion to be had. I won't get into the details like too much here. Yeah, so it's on Unichain. I think it could be on any chain after that. More performance optimizations out in the open. So I think like the real alpha here is like what happens if you put a bunch of Chad and Chadettes, performance optimizers in a room, give them open source software, like open source benchmarks, and have them actually, iterating together in the open. I think that is the rocket path to a gigagas sequencer. I think there's a lot of discussions and a lot of projects that claim they have these like benchmarks, but I would say like if there's a claim and there's no benchmark, just like don't even entertain it is what I would say. I'm a little bit overzealous about these things, but yeah, I think I think the optimism ecosystem has like the strongest path towards this because there is so much actually like interesting performance. There's a lot of interesting data sets and like real world use cases here that we can actually optimize for, as opposed to just like theoretically optimizing for them. And everything's also open source, so I think we have everything we need there. Yeah, I had another comment on distribution. I'm just going to skip that. So Subcent intelligent resource pricing. So I think we at Flashbots think this is going to be another big part of rollups is your state contention policy. This could also be your MEV policy in some cases. They're almost synonymous, slightly different. I think really the impetus for this is like there are some superchain chains that, like Base is one of them, that has seen up to 50%, slightly over revert rates from bots spamming the chain. And so I think you either need like something like a proof of personhood, or you need to like actually sort of manage the resources on your chain such that they're not overwhelmed by bots. And we like to point at the MEV trilemma a lot. So this is the idea of like you either choose a latency auction, a spam auction, or you design an explicit auction, and you kind of hope that that explicit auction leaves the trilemma. Otherwise, you could, if poorly designed, end up back in the other two. But so you can lead into first come, first serve. It's super duper simple. Like I think it is elegant how simple that ordering policy is. And it's hard to sort of estimate how like useful that is in a complex system. But generally it's always going to result back into a latency race. It's just who's going to be the closest one to the sequencer. I think depending on your app, that's a valid trade-off. We generally view that as like how most like centralized exchanges work, or like traditional financial markets. So we typically tend to avoid that, but I think it's a valid decision point. You could just use 1559 in a private mempool. As we're now seeing with like very conclusive data, this leads to massive spam auctions. I think the superchain, some of the chains actually have the greatest data sets on this, which is super cool. As mechanism designers, like that is what we need to actually push forward. Otherwise, it's all just conjecture. Yeah, and then explicit auction, we think that's the way. Yeah, if you have a use case for your chain and you need a design, feel free to chat with us. We're happy to give recommendations. We won't force you into our software or anything like that. We just want to make sure MEV is handled well. Yeah, and then revert protection is also another interesting one in terms of like contention policies, because you could have anecdotally 20 different searchers competing for the same opportunity and only one of them wins. And you have this interesting dynamic where like economically they're all paying now, maybe a couple of cents for their failed transactions. But on top of that, it's not just them that are paying, it's also the chain, because now we have like 20x the DA usage for like one opportunity. So yeah, I think that's another like interesting alternative route. I also think it is interesting to note, like I think a revert is like a cent or less than a cent last I looked on Base. And so if you're competing on opportunities that just make $1, you can try 100 times. And so I think every time we've seen chains grow their throughput, we've also seen spam grow almost proportionally. We're trying to work on some data actually to publish on this. They're starting to get sneaky. I think they've been watching our talks because they maybe it's one of you. Yeah, and then okay, this last one is very interesting. Zen. If anyone knows anyone at Zen, can you connect me? It's like, in the weirdest way, it is like a virus that has inserted itself onto every chain and is like now this like big boss that all the performance optimizing engineers need to battle. And I think in an open source perspective, that's like really beautiful. But practically speaking, I've heard anecdotally some chains take over 100 milliseconds to pull the relevant state to execute a Zen related transaction. And so if we ever want these pre-comps to go lower than 100 milliseconds, we're going to need to figure out something to do with Zen. And I don't know the mechanics of it too well, but I really think we're just like pricing storage poorly, is like what our suspicion is. Yeah, and then horizontal scalability. I think this is also another tenet. You know, when I deploy a Lambda or something onto AWS, I just like hit a button, and now I have like, you know, auto scaling capabilities, and so we need that for internet scale rollups as well. Yeah, that's an area of research we want to help pursue that we're not currently doing anything related to Rollup Boost with. Permissionless and safe. Yeah, stage 2 ASAP, please. It's like not really controversial, and I won't pile on by saying it. I'll just add in some quick points. So we've built a proof of concept with Automata of TE validity proofs. The term validity proof is like a little bit misleading with a TE. It's actually more like you're getting a signature of the correctness of the execution. It's not like portable like ZK. But I do think if you combine this with like succinct and any other ZK validity proofs, you could have this multi-prover, which is like 2 ZK proofs, maybe 2 TE proofs, kind of gives you the defense in depth. Decentralized sequencer is hard. So code complexity at what user benefit? Like, I don't know about you guys, but not many people really come up to me and say like, hey, we need to decentralize the block builder, other than just like, hey, I'm scared of these big block builders. Most users don't really have an opinion though, and so that's why it's like up to us, everyone listening, to actually decentralize these components. But it's just always been deprioritized, I think, because of lack of user benefit. There's also very complicated social structures at play, I would say, in adopting software for this. Our answer, we think it's very simple. Just decentralize the operation of your block builder sequencer with TEs. Now you can have 2 to 3 parties. They're all running the same thing, but you actually get like some claim to neutrality of the operation, and you get these like cool, availability benefits. Lastly, this, or second to last, this really gets into like it gets a lot into decentralized sequencing, but sharing order flow is really hard. And this gets into the safe part about permissionless. So we've gone down every single path. The most naive thing you can think of is like, okay, reputation. So I'm just going to, pick these 3 people, and I'm going to just give them the order flow, and now they're allowed to build blocks. Like no issues. They can sequence for my chain. Maybe we do like a rotating leader set. That's fine. But what if one of those parties starts inserting malicious transactions? Then you think, okay, cool. We'll do like some consensus magic on top of it. Okay, well that's expensive. And then B, what if the other party actually just starts selling the information? And so they just go to Citadel and say, hey, look, we have this like 20-second heads up on this flow, like want a copy? And so that's where we get into like cryptographic primitives. And so MPC, FHE, ZK, hell yeah, like love it, just not here yet. We've done benchmarks in all of them. You can check on our writings site. MPC, I believe, was 20 minutes to compute an arbitrage. So that's not even like building a block. That's just like, hey, a trade happened. Like, let's compute this arbitrage. FHE was like in the hours. I forget the exact amount. And then ZK also like hard to even compare. Anyways, I do think there is like a fully homomorphic encrypted version of everything we're building in like 3 years, but it's just like not here, and we need a lot of this tech now. So yeah, and again, reputation is also broken. Like we could try to like slash people if we find them leaking, but what happens if they just build up a ton of reputation, hit a 20 mil heist, and then leave? Like it's very hard to do these types of designs in permissionless systems, and that's why we've, as a collective, have ended up at trust execution environments. We think they provide operator privacy and stronger inclusion guarantees, plus a credible path to decentralizing the sequencer. Customizable. I'll just run through these. I mean, we think you should be able to modify the transaction ordering policy super easily. Custom system transactions if you want to put like an Oracle update at the top of the block, or you want to do some massive computation or something, like, you know, that should all be free game. Custom confirmation rules also could be very interesting. I think there's a bunch of design there. Like, I think the Celestia people have a lot of cool research there. Like, you know, proof of burn. Like, you know, whichever block burns the most tokens is the one that gets confirmed. I don't know, kind of crazy stuff. Yeah, more unique state, the better. I think, you know, the thought experiment is, would you rather like 100 general purpose chains or a couple with like a very unique state? And I think, yeah, two concrete examples of this are Unichain and World. I think they will both have state that would be extremely hard to replicate just on your own on a different rollup. Yeah, and then here's like my cheesy, I would say, closing out of this section. I defined rollup boost earlier, but I really think it's a path to supercharging the superchain. What are we doing to get there? All right, I'll just skim through this. We're actively collaborating with World and Uniswap. Go use the World incentivized testnet. Go ahead and break stuff. That would be super sick, so that we know, you know, we get a heads up before it goes into production. There's a bunch of code bases we're working on. Rollup Boost. If you actually zoom in, you can see Uniswap and World's contributors there, and Phylax. So we're kind of excited about that. 4 different teams. I forget who the other one is. OPR Builder. This is the like super customized high performance block builder we've been building in the open for Optimism. Contender, this is a high performance load testing tool. A lot of the load testing tools just kind of do a transfer. We want to do things like actually complicated MEV strategies to see how they perform. We generate these cool reports when you run it as well. You can see this cool like storage slot heat map, which gets generated, and there's like a bunch of other stuff. Yeah, and then we have some cool designs on how to properly benchmark stacks. Here's the links. Also chat with me if you're interested. Feel free to just post issues and feature requests. You know, we have KPIs to answer as fast as possible, and we also want to like help you ship them as well. Yeah, all this code, open source, day 0. No questions, no restrictive licenses. By the end of Q2, we also want to have all of our R&D conversations in the public. We're trying to follow in Optimism's steps there. Yeah, here's the last side. We're hiring. Yeah, come help join us. I think we could ship Flash blocks to the entire superchain by Q3 if Flashbots had like 2 more good engineers, 2 more Chads, Chadettes. That's it. Thanks.
Thank you so much. Are there any questions? Any questions? All right, awesome. There you go.
Thanks for the talk. Super fun to always listen to what you have to say here. Also, super interesting topics. The one question I had was, what is, I guess, a viable approach to revert protection that you see, like many chains being able to adopt? Does it slot into Rollup Boost? Is it implemented at the builder level? Like, what's a simple and easy way to enable revert protection such that you don't encounter as much spam?
Yeah, I definitely recommend not doing it at the protocol level until we understand the dynamics of internet scale rollups. Because I think this like reverting spam, we did not guess it was going to be this large before, like when, you know, all these L2s started popping up. So I think that's the tricky part about mechanisms, is there's always people breaking them, and the fun thing. So yeah, I think do it at the builder level so that you can fall back to including them. It's not a massive chain degradation in most scenarios, especially if it's like a lot of these bots, like they're already doing this. So, you know, if you have to fall back to that, that's like probably okay. Long term, yeah, it is also another, you know, resource pricing problem because you're just giving all this potentially free compute away. There is super cool stuff like I think they're called RLNs, rate limiting nullifiers. The idea that like each key gets like a certain amount of usages, and once it goes past that, you start charging. Again, that's not like Sybil resistant. On L1, what we do is, and we've gone like back and forth on this mechanism. We've seen 10,000 like transactions per second sometimes, and haven't needed to do anything. Then there's like one annoying searcher who like, you know, I no idea what they're doing. There's some cool ones like this one-eyed blind man who that's his name. Sorry, that's not like that was his like searcher name. He was doing this thing where he would put the last block's Coinbase balance into the call data, and so this would tell him. He would check that before, or they would check before they do their smart contract logic or like the swap logic, and it would tell them whether or not they're being executed at the top of the block. And so then we started doing funny stuff, like we'd introduce like a random amount that we insert into the balance at the top of the block and then like remove it before. But anyways, yeah, we have this reputation mechanism, and how it works is it's just the more ETH you contribute to the block with less gas used, the higher your reputation is. And then we have two block builders, one that's a high reputation only, then the other one just does everything. And it's really only in these rare sequences that the high reputation one actually is actually not under-resourced while the other one is. A lot of people would say, it's a really interesting discussion though, because a lot of people say that's censorship. Yeah, I think it's, that's all I got for you.
Any other questions? All right. Actually, there we go.
When will the customizable, like the customizing it will be, when will that be live?
Right now, what do you want?
We run some of our own version of this kind of. That would be better if it was in a decentralized, like a TE or something like that. So we should talk after.
Cool.
I guess.
Yeah. Let's totally do it.
Sweet.
Cool.
All right, guys, thank you so. Oh, sorry, we have one more question. There you go.
Just a question around the sort of roll-up boost, you know, in terms of, so from a chain's perspective, what are the key steps they need to do in terms of chain? Like, how much of this is something that the chain themselves have to run? How much of it goes to like, you know, how do you anticipate a world where this becomes like a service? You know, for scalability of the roll boost. That's one question. And then the second question is more like the debate that you raised earlier, which is, you know, you could always increase the actual speed of the sequencer versus pre-confirmation. So what's your take on that in the long run, you know, yeah, about this situation?
Yeah, totally. So on your first question, the sequencer, the OP-Stack chain can run all of the software if it wants. And so, yeah, it needs to run this sidecar and then a block builder component. Eventually, that might just be like one component as well to make it easier. From our perspective, we are hoping that there's like something like a network of T block builders that a chain could just like rent. Yeah, I think we're sort of very early in thinking through that. I think a lot of the ideas in Polkadot are very interesting with this like idea of like core time, that you could just like rent a core on this network. So I think that's kind of inspiring. And then on the second point, on the blocks. Yeah, well, so I think that the trade-off is the larger blocks are harder if you have a lot of nodes, because they need to all propagate and receive this data and then vote on it, and it's just larger payloads or more frequent payloads. And so I think it's an interesting approach to have these pre-comps, because it's kind of like a fast lane and a slow lane. Like you do the consensus in the slow lane, and then you have like the fast lane be the sequencer, these sequencer pre-comps. And yeah, you could still like rotate leaders for those and other things.
Okay, makes sense.